Hi, I'm Andrew, and this is part 5 in the Advent of Code series where every day I'm trying to solve a new code challenge. If I'm able to solve the challenge, I will upload any code that I write onto a public repo. The link for that is in the description of the video. But for today, let's get started with part 5. So we're looking at supply stacks. The expedition can depart as soon as the final supplies have been unloaded from the ships. They're stored in stacks of marked crates. The needed supplies are buried under many other crates, and the crates need to be rearranged. The ship has a giant cargo crane that can move the crates between stacks to ensure none of the crates get crushed or fall over. So the operator will need to rearrange them in a series of carefully planned steps. After the crates are rearranged, the desired crates will be at the top of each stack. The elves don't want to interrupt the crane operator, but they forgot to ask which crate will end up where. They want to be ready to unload them as soon as possible. They do have a drawing of the starting stack of crates and the rearrangement procedure, which is our puzzle input. So an example is, looks like we have these lists of characters, which is saying that we need to move 1 from 2 to 1, move 3 from 1 to 3. Okay, so in this example there are 3 stacks of crates. Stack 1 has 2 crates with Z at the bottom and at the top. Got it. Stack 2 has 3 crates, and stack 3 has 1 crate. The rearrangement procedure is given. In each step of the procedure, a quantity of crates is moved from one stack to a different stack. And it looks like that is maybe what that number says, or maybe not. First step of the above rearrangement, 1 crate is moved from stack 2 to stack 1. So that would go from here to there, which gives us this configuration. In the second step, 3 crates are moved from the first stack, so that takes all of these and puts them on top of this one. Then both the crates are moved from stack 2 onto stack 3. And then lastly, 1 crate is moved from stack 1, and 1 is moved to stack 2. So the elves just need to know which crate will end up on top of each stack. In this example, the top crates are C in stack 1, M in stack 2, and Z in stack 3. We can just add them together then and return CMZ. So this is the first challenge where we're not just returning a number, which is the count of something, we're returning the code representing the boxes. So our puzzle input is going to be something like this. Let's take a look and get into it. So what we have is sort of a graph that we're going to have to figure out how to process here. And then the list of instructions underneath. So we'll just copy that over. Okay, so the first thing that we're going to want to do is process these stacks and get them into a list. And I think we can actually use a stack data type to store these, because when we move one crate from a stack to another, we just take the top one and then move it one at a time. And I think a stack would be great because we could just pop whatever's at the top of the stack, and we can always just push onto a stack to build it up. So what we can do is we're going to need to separate this file out into kind of these sections. Definitely the crates, and then the steps will have to be separate. I don't know that we really get much out of these numbers, so maybe when I process this, I could just kind of cut off, this section and then just use the logic here. The tricky thing is that there's spaces in between these, so we can't just split by spaces, or else these crates will end up over here. We can't just split by the brackets either, because the same thing's going to happen. One thing that we could do, since we know that even if there are spaces here, they are still they still take up space. So we could probably, for each of these lines, we could probably chunk them by maybe 4 characters. And so every 4 characters, we're going to have a new set. And that should follow all the way down for each row. And then we can just iterate over to map them out to their own columns. So that'll be the first thing to do, is just make a function that takes this, the first 8 lines, and well, actually the first function should split these out, and then we'll make another function to process this. So I don't want to rely on the index just because I know that it goes through 8. I would like this to work with really any kind of data set in the same format. So I will write a logic that splits the first line out that doesn't contain any brackets, and then I will start a new list of lines that starts with move. Yeah, so let's start with that. We'll say, call it a list of strings and call it separate file as an extension function. Separate file sections. And that's going to return a I guess a list of strings. Actually, since it's going to be a pair, maybe we could just do that. A pair of lists. A pair of string lists. There we go. So, yeah, I think that's good. And the string for both types. Now what we'll do is, oh, right, we put 2 types in the list. We need 2 types for the pair. So something like that. And then what we will do is look for the first line that doesn't have the brackets. So we'll say first, index of first, and we're inside of a string, so each line is a string, a single string. So the first string that doesn't contain a bracket, we could check. So index of first contains a bracket. It would be a little better solution to use a regex for like digits or numbers or characters, but this will work for what we're doing. So the index of the first, that's going to be stop. So we'll say group 1 end is going to be this index, and then we'll say group 2 start is going to be index of first. Oh, and for this one, we need to say the first index that does not contain. So I need to invert that. That would have been bad to miss. So here, the first one that contains the word move, I think would be sufficient. So for this, we'll say first that contains move. And then we just need to return the 2 subsets with those ranges. And we'll do that. We'll return a pair, and we'll say sublist. We're starting and we're ending on group 1 end. And then for our second part, we are sublisting. We're starting at group 2 start, and then we're ending at the size of the list. That might not quite work depending on how it sublists if it's inclusive. So let's just run this and see what we get. Might have to add 1 or subtract 1, but let's just start with that. And we will just set a value to it. So I'm going to destructure that declaration and say group 1, group 2 is equal to the input separate file sections. And then we'll just put a debugger and look at what those values look like. Okay, and it looks like it ran, and the first group has 8 lines, and that's correct. So it starts with M, ends with B, and then group 2 starts with move 5 from 3 to 6. Move 5 from 3 to 6, that's our first one, and then the last instruction is move 2 from 7 to 3. Let's just, instead of reloading that, we'll just evaluate the expression for the last one. Group 2 last. That is move 2 from 7 to 3. That's what we're looking for, right? Move 2 from 7 to 3. So that splitting logic is good. We've got our 2 different sets. We have instructions and crates. And I think I will rename them here too, so it's more clear. We'll say crates are group 1 and instructions are group 2. So now what we need to do is take crates and split them out into lists of characters, or we're going to chunk them. So crates, we could say chunked, and I think it's 4 characters. So if we did 3, we would have 1, 2, 3, and then it would start out on that empty, and we would kind of end up losing characters. So we'll do 4 at a time for chunked, and yeah, and so the last one actually won't have a space because it's the first one that doesn't have a space after it. So this one, it'll end with a list of 3, but that's fine. And yeah, let's see, what are we going to do with that? We need to transform it into stacks. So we could say, we'll say a stack list. We'll say mutable list of stack of string. We gotta import stack. Okay, so we're gonna need that, but for now, let's just look at what our chunked crates look like. We'll just say, we'll just set a value here so that we can evaluate it. Run another debugger. So our crates in the group, we have crates is, oh, right. Right now the list is showing kind of top to bottom, so I did 4, so that's just taking these 4 lines and these 4 lines. So what we need to do is we need to map each string into a chunked list. Okay, so we can say crates map it chunked for 4. That will be what we're looking at. Okay, rerun that. So we should have a list of 8 under X. We do, and each one is 8 long, which I think is right. They're 8 wide. Oh, interesting. They're not. They're 1, 2, 3, 4, they're 9, but oh, some of them are 9, some of them are 8. That could be challenging, and that's because these ones, okay, that's because these ones that don't have a ninth column, they just stop here. So that actually makes sense and should be fine. So if we look here, we would have M as the first one, and then N and Z at the end. Yeah, so I think that's fine. What we will do is we will just strip these characters, the brackets, out, so that we would just have M, N, and Z to make it easier to work with. So let's do that. Chunked, and we will map each of these strings to let's see, chunked is a list, map is going to return still a list, so we'll say it replace, I guess we could just do this, we could just replace opening brackets with empty string. We can replace closing bracket with an empty string. We're kind of getting ugly code here now, so I'm just gonna try to split some of this out and add some names. So if we look at these values, we should have stripped out the brackets from the list. Yeah, so we've just got M and Z. Yeah, so then any logic from now on, we can just strip. Actually, we can even do that here. We'll just trim them, and so there won't be any spaces. And then so these ones we could just check if they're empty. Otherwise, we'll just have the letter trimmed down. So then what we could do with those values is we're going to go back over them and put them into the stack list one at a time. And I think we could do that here. So for each list of strings, we're going to I think do indexed, and we can create new stacks based on what they have in them, but yeah, because what we're gonna be doing here is going across, and for each one we want to add it to a stack. So actually we need to do this for first. We need to take the list because we need to start at the end. Otherwise these stacks would be upside down. So that was a good catch. I think we can just reverse it there. Reversed. And then for each because each one can have a different size, we're going to need to do indexed here and stack list. I guess we'll just keep creating mutable lists inside of this or we'll keep adding stacks to this list until we run out. So we'll just do that logic if stack list size is greater than, well, first we need to check if the stack list's size is less than the index, less than or equal to the index, then we need to create a new list inside of stack list. So we'll say add stack. That'll be an empty stack. Does it have to be I don't think it has to be a mutable stack, does it? Is that even such a thing? Mutable? No, I think a stack already has its operations on it. Okay, so That's what we'll do and say from there, we will take stack list, we'll get the index that we're currently going across, and we'll say stack list, and we will push the string. I don't know why it's strings, because it's just a string. Or is it strings? We do have a list of strings. And that is because we need to okay. That's because we need to do an for each inside of here. Because here we're going down vertically, and then here we're going down horizontally across. I'm sure there's a better way to represent this, but for the sake of solving the code challenge, here we are. So this is what we'd be doing. So let's run this and see what the stack list comes out as. Stack list, we have 9, which is expected. Some don't have that many. Like this one, for example, only has 5. Yeah, okay, so let's take a look. Stack list 0 is full. That's because they go all the way up. Stack list 2 should only have 3 values that aren't blank. That's NBL. So they're at the top here because that's the start of the list, but actually it would be like this. So if we wanted to move one, we would pop the list and then we would push the list. Yeah, but what we probably want is to actually get rid of these empty values when we're creating the stacks, because otherwise it could, if we push one, it's going to sit up on top. So that's one thing to look at, but otherwise, I think we're good. So if the string is not blank, then we will put it onto our list. Run this again just to make sure, but yeah, I think that will be more accurate. So here we are. Now we have 8 in this one. There's only 3 in this one because the rest were blank. Okay, so now our stacks of crates are in a data set that we could work with. Now the next step is going to be separating these instructions out into something that we can use. And I think we're probably going to want to just make a data class to represent this. And we'll say quantity from and to, and then we'll just map all the lines into those. So we'll create that here, data class, and we'll just call it an instruction. And we'll say that there's a value of quantity, and that's an int. They're all ints actually, from and to. So then what we can do is take the instructions, map it to those data sets, or those data classes, and then we'll just iterate over the instructions, perform it on our stacks, and we should be able to return the answers at that point. So instructions will go map. So each line is going to end up being a instruction, but we need to take our values and say the quantity is going to be something, the from is going to be something at 2. And we'll probably just split the list, split the string by something. We can split it by spaces and just take these specific indexes. That's fine. So we'll take we'll just make a split string and take it split by spaces. And we'll take this one, will be split string, and the index of the quantity is going to be the first. And we'll copy this over. Okay, so then index is going to be the first is here. This will be the second, this will be the third, fourth, and fifth. Okay, and then we'll just put those into our data class. So quantity from 2. And that's because we need to put these to string integers. Okay, and so once again, we're just going to set a temporary value there and debug to see what it looks like. So the instructions, there's about 502 it says. That's about what we have, our list. And what do they look like? So the instructions, right, we don't want to know about the instructions, we want to know about the map in X. So quantity 5 from 3 to 6. I think that's about right. Quantity is 5, we're moving from 3 going to 6. Okay, I think that is reliable. That should be all we need for now. Yeah, pretty sure we could just go ahead and complete the challenge from there. Yeah, so we've already filled out our stack list by this point. We don't need to really do anything else. So instructions, we'll just go over the instructions, perform what we're going to perform on the stacks, and then return our value. So stack list. Okay, so for the instructions, we're going to okay, so we're going to take the instruction, the quantity, and we're going to call repeat on that. Quantity, oh, we're going to repeat, that's a function. Repeat the quantity by this many times. And we're going to just name this because we might get nested a bit. Instruction. Okay, and we're going to repeat this. And we're going to take our stack list. The index is going to be from our instruction from, and we're going to take stack list, the instruction 2. We're just going to pop it, or we're going to push it straight from the pop, because when you pop an item, you get that value as well. So kind of consolidate the logic. Instruction 2. We're going to say, oh, instruction 2. It's getting messy, but I think we're almost there. 2. So from here, we're going to push stack list where it's coming from. We'll pop. And I think that's all we need to do. And then I think we could just look at the list and take whatever ends up on the top. So yeah, let's take, we're going to return a stack list. We're going to map it into, let's map them all into the last item from them. Join them to a string. Yeah, I think that's it. Here we're returning a string instead of a integer. So yeah, let's see what it gives us. Oh, and here we're still returning a number. Okay. So let's check the output. And we got a crash. So what happened? Here, what happened? It just an exception. Okay. So we already know that quantity is how many times something's going to happen, so that repeat is good. And we know that, yeah, so we're just going to log this and see what it's saying when the error happened. So let's print and say, say moving oh, you know what? I bet that's what it is. This is saying that we're moving, yeah, so our indexes are up by 1 because this thinks that there's probably, like, there's probably a 10 in here, even though we just have 9 rows. 2, 10, no, 9. Oh, well, right, there is 9, but 9 wouldn't be the index of 9. So, all we have to do is take these and reduce them by 1. Simple mistake. I don't think we have to print anything now. I think it should work. We're probably getting an index out of bounds. Yeah, okay, so here is the here's the list that should be the result. I'm just going to join them to string without a comma. Hopefully it just puts it in 1. Yes, there we go. So this supposedly would be the correct answer. Let's take a look. Submit, and yes, that is the right answer. Good. So we're going to move on to part 2, and a lot of the logic I already wrote was kind of customized for this, so wouldn't be surprised if this kind of throws a wrench in things. And that is long part 2. So let's see what it wants us to do. As we're watching the crane operator rearrange the crates, the process isn't being followed. Some mud was covering the writing, and you quickly wipe it away. The crane isn't a 9000 version, it's a 9001. So there's new features on this one. The ability to pick up and move multiple crates at once. So, okay, that probably just means that we're not doing one at a time. We're probably just doing a whole set and putting them in place. Moving a single crate from stack 2 to 1 is the same as before. But now, when we move 3 crates from stack 1 to stack 3, they stay in the same order. Yeah, okay. And now, final 1 crate is moved from stack 1 to 2, but now it's crate C that gets moved. I think that's what had happened up before too. Oh no, they were reversed, so M was at the top. Okay, so it looks like that's the only change then. That's cool. We just don't have to do some of this using the stack, like pushing and popping. Yeah. I guess we can just use lists then. I mean, stacks would work, but I just don't think it's necessary at this point. So we'll just say mutable list of strings as the type, and then our mutable list with strings. And then here we will do the same exact thing, but we're going to, yeah, it's still going to add, but it's not going to add a stack. It's going to add a mutable list of in the type. And then for this one, instead of pushing, we're going to just add that string. Everything else is about the same, but it's here, instead of repeating with this pushing and popping, we can just take stack list 2. We can just add all of the elements from the sub list and stack from, or in the list we're going from. So stack list, still a stack list, even though it's not stack. Instruction, we're going from. Oh, whoops. Just going to remove this. We're going to sublist, and it's going to be the the stack list. This is getting to be a lot. I'm going to just name these lists. We're going to name 2 list or 2 stack. Which is going to be this. And we're going to do from stack, which will be this. Okay, so now we can do this a little simpler. Well, not really simpler, but just with less clutter. From stack is going to be the from stack's size. So the starting index should be the size minus the quantity of the instruction. And then the end should just be, you know, we can actually just use drop last, I think, for this from stack. That'd be great. Drop last. Yes, okay, so, or take last, I mean. So we're going to take the last quantity of the list, of the instruction quantity, and that will just grab whatever's on the top of the list. Yeah, I think that will be good. See, no way is it really, it's really just all V's. Wow. I guess we'll see if that's right. I'd be surprised. It's not the right answer. Yeah, okay. So I wonder what went wrong there. Everything here is still going to be the same. Our instructions are still the same. The only difference is in this logic. So, and that, you know, why that is because we're not taking them from the list. So that it makes sense. So what we will do is when we add them from one list to another, we're going to say the from stack is removing, remove last. We can't really do that. Last while. No, that's fine. We'll just say that, man, is there not just a way to drop retain all? What does that do? Retain all, does that drop? No, I don't have documentation. Well, we play around in the debugger. Yeah, because that's all we need to do is just remove those items. So what would happen there if we take from stack and we look at it? It has these 5. If we say retain all of from stack, dropping the last 3. Oh yeah, okay. It gives us a result. I don't know that that's really helpful. Well, okay. We'll just say, for simplicity's sake, we'll say that the instruction quantity, we will repeat that and just remove the top item from the list. Maybe maybe we should have stayed with the stack after all. Yeah, so repeat for that, and we will just take the from stack and remove last. I think that's fine, and we won't get all V's again. Okay, so this is the new output. Let's test it. Okay, we'll try our answer. And we got the right answer again. I'll just follow up tomorrow with a new video.